Hello and welcome back to my YouTube channel. Myself, Mesra. Today I'll be talking about the chapter from physics portion of class 9th, work and energy. Okay, but here I will only discuss the questions, and in this way we will be clearing the concepts too. Okay. So let's start our journey with this question, which is here and on this page. Okay, so first question, it reads: a force of 7 Newton acts on an object. The displacement is say 8 meters in the direction of the force. Let's take it that the force acts on the object through the displacement. What is the work done in this case? Here you have given an object, and the 7 Newton force acts on this object in this direction. And this object displaces 8 meters, right? So you can see here the 8 meter displacement and 7 meter force. And we know that we have to calculate the work done. Okay, so the formula for work done is force multiplied by displacement. Here force is 7 Newton, as you can see here, 7 Newton multiplied by, and displacement is 8 meter. Okay, so 7 into 8, it's 56 Newton meter. Okay, so Newton meter is nothing, it is Joule. Okay, so it is 56 Joule. So work done is equal to 56 Joule. So this is the answer of first question. I think it's clear. So let's move forward, and let's talk about another questions on the next page. Okay. So here are a few questions you can see. So the question number first is, it reads that when do we say that work is done? Okay. So when do we say that work is done? Okay, so let's discuss this question. Work done formula is force multiplied by displacement, right? So work done is said to be done when force is applied on an object. You can see here, if force is 0, that means work done will be 0, right? So if force is 0 here, and whether displacement be anything, this quantity will be 0. Okay, if force is 0. And if force is there and the displacement is 0, this quantity will still be equal to 0, right? So there are two conditions for work to be done. First one is force should be applied, force must be applied on an object, and second is that object must displace some, object must displace. Okay, so I would say that when do we say work is done? Work is said to be done. Work is said to be done when force acts on an object. When force acts on an object and object moves some distance. Okay, so these are the two conditions for work to be done. First one is force must be applied on an object, and second is the object must displace some, it must displace. For example, I will show you with an example. For example, this is an object of mass m. If I applied the force here, and if this object does not move, that means work is not be done here. Okay, and if this object moves some displacement, for example, if it moves here and it moves some displacement s. Okay, so I can see here this object has been displaced, and force is also done. That means work done here, it will be something, it will not be equal to 0 because it displaces and the force is applied on the object. So work is said to be done when force acts on an object and object moves some displacements. Okay, I think this is clear now. Let me clear this drawing. Okay. So the question number second is, write an expression for the work done when a force is acting on the object in the direction of displacement. You must have studied about the work done formula is equal to force multiplied by displacement. And there are three conditions. So one is when an object, if a force of some magnitude F acts on an object and the object moves some displacement, right? You can see here this force and displacement, they are in the same direction. They are in the same direction. Okay, force is from here, from left to right, and the displacement is also in the same direction where force is applied. So here I can say that work done here is positive. So work done is positive when force and displacement are in the same direction. This is the first condition. Okay. Second, if the force is applied in this direction, say, and if the displacement is in the opposite direction, okay, displacement is in the opposite direction. So force and displacement here are in the opposite direction. So work done will be negative. Work done will be negative. That means here it will be some 50 joules, 100 joule, 1000 joule, right? And here it will be minus 50, minus 100, minus 1000, like that. Okay. Okay. And third condition here is if the force is applied like this, perpendicular direction on an object, and the object moves like this. Okay. That means force and displacement have 90-degree angle. This is displacement and this is force. So these two have 90-degree angle. So in this case also, the work done will be here 0. Okay, work done is equal to 0. When is work done 0? When force and displacement are perpendicular to each other. Okay, when force and displacement are perpendicular to each other, work done is 0. So I think it's clear now. Okay, so let's move to question number 3. Define 1 joule of work. Okay, so we will define 1 joule. So let's start from the formula. Work done is equal to force multiplied by displacement, right? So joule is the SI unit of work done, as you already know, right? And here, when will this work done be equal to 0? When F is 1 and S is 1, right? So 1 multiplied by 1, it will be 1. That means 1 joule. So I can say that when F is 1 Newton and displacement is 1 meter. Okay, so this is 1 Newton meter. So 1 Newton meter is nothing but it is joule. So I can say 1 joule of work when force acts on an object, when 1 Newton, when 1 Newton of force is applied on an object and the object moves 1 meter distance. Okay, for example, if here it's object and we apply a force of 1 Newton and this object moves 1 meter. This object moves 1 meter. Okay, so here work done will be equal to 1 joule, right? Okay, so I think it's clear. Let's move forward. Okay, so let's concentrate on question number 4. A pair of blocks exert a force of 140 Newton on a plow. So you have given here, I will simply write given force is equal to 140 Newton, right? The field being plowed is 15 meter. So this 15 meter is nothing, but it is displacement, right? So this is 15 meter. So we have to show how much work is done in plotting the length of the field. So we have to calculate work done. So work done is equal to force multiplied by displacement. And force here is 140 and displacement here is 15. So this is equal to 2100 Joule. Okay, work done, 2100 Joule. Okay, so let's move forward. Let's move to another page. Okay, so here are the series of questions which you can see here. The first question is, what is the kinetic energy of an object? So here you can see that the topic has been changed. The first topic was about work, and now it is about energy, because our chapter is about work and energy, right? So we have covered the work portion, and now it's time to cover energy portion too. So the first question is, what is the kinetic energy of an object? Okay, so kinetic energy, kinetic energy is, if I write its expression, if I write its formula, it is 1 by 2 mv square, right? It's 1 by 2 mv square. So you can see here mass, and where m is mass, this is mass, and v is velocity, right? So this is velocity. You can see that velocity and mass, they are in product. That means they are in multiple, right? So if velocity is 0, kinetic energy will be 0. And this mass cannot be 0 for an object, right? So for a matter, mass cannot be 0. So the condition here is that, if kinetic energy has to be 0, then velocity must be 0. Okay, so we can conclude here that that if an object is at rest, that means the object has 0 kinetic energy, because it does not have any velocity. That means it has not any kinetic energy. So this means that object has only the kinetic energy when it is moving, when it has some velocity. Okay, so I can write here the energy possessed by a body by virtue of its motion, by virtue of its motion. So this motion is important. That means if an object is moving, then only we can say that kinetic energy exists in that object. Okay. The second question is, write an expression for the kinetic energy of an object. As I have already written it here, 1 by 2 mv square. So this is an expression for kinetic energy, 1 by 2 mv square. Okay, where m is mass of an object, and v is the velocity of an object. Okay, so this is the expression. Okay, so let's move to question number 3. The kinetic energy of an object of mass m moving with the velocity of 5 meters per second is 25 joule. So here we have given that kinetic energy is equal to 25 joule of an object of having some mass m, right? So this is 25 joule. So we have to calculate what will be its kinetic energy when its velocity is doubled. So if I double the velocity, for example, if firstly velocity was, this velocity was v. Now I have doubled the velocity. That means the velocity will be 2v, right? So what will be the formula? The formula is 1 by 2 mv square. Kinetic energy is equal to 1 by 2 mv square. So you can see here, if I put this 2v instead of this v, because v is doubled now. So this expression will become 1 by 2 m into 2v square, right? So this will be 1 by 2 m into 4v square. Okay, 4v square. So kinetic, I can have this 4 out here. This is 4 times 1 by 2 mv square. So that means kinetic energy has been increased by 4 times. Has been increased by four times. When velocity is doubled. When velocity is doubled, kinetic energy will be increased by 4 times, because here we can see that velocity is, it's not simply velocity, it's velocity square. So if velocity is doubled, that means it will be 2v square. That means 4, 2 into 2, 4, right? So if first kinetic energy is 24v and we have increased the velocity by 2, that means doubled. That means kinetic energy is 4 times, as you can see here. So kinetic energy will be 4 into 25 joule in the second case. That means 100 joule, right? Okay. So the third condition is when its velocity is increased 3 times. So when its velocity is increased 3 times, what will be the kinetic energy? I will erase this one. So here kinetic energy increased by 3 times. So if kinetic energy is increased by 3 times, that means 3v. So kinetic energy, the formula of kinetic energy is 1 by 2 mv square. So this is 1 by 2 v square. That means now we have 3v instead of v, because we have increased it by three times, right? So this will be equal to 1 by 2 m. 3 into 3 is 9 v square, right? So I can have this 9 out here, 1 by 2 m v square. So you can see here, this is kinetic energy simply. And kinetic energy has been increased by 9 times, 9 into kinetic, 9 multiplied by kinetic energy. So when velocity is increased by 3 times, kinetic energy is increased by 9 times. Okay, so firstly it was 25 joules. Now it has increased it 9 times when velocity is increased by three times. So that means 9 into 25 joules in the third case, right? So 5 into 9, 45, 5 carry, 2 into 9, 18, 18 plus 2, 225 joules in the third case when the velocity is increased by 3 times. Okay, so it's now I think it's enough for today, and remaining question we'll be discussing in the next video. Till then, take care and have a nice day.